course, the question that we get is how long will the hose last? And much like the question we get, how long will a diaphragm last on all of our ProMinent pumps, such as the Sigma, the Gamma L, the Delta, it's very difficult to answer that question. There's so many factors that play a key role in that. The biggest factor with the hose pump, with the Dulcoflex, is the speed of rotation. We'll talk about that in depth. That's going to be a very key limiting factor for us. The temperature, the warmer, the hotter the product going through the hose, the lower the life expectancy of that hose will get out of it. Of course, the process chemical, that's important to us, just like with the material of the liquid end for our other pumps. If we get that wrong, of course, it's going to lead to a very short lifetime for the hose. If we get it correct, it will increase the life expectancy of the hose. But it is important that we get that correct. Just like our other pumps, the process chemicals, also the process conditions, the suction conditions, as well as the discharge pressures, discharge conditions are going to play a very key role in determining how long that hose is going to last for us. It's very important that we address any poor hydraulic conditions, just like our mechanically actuated pumps. Those hydraulic conditions can really shorten the life expectancy of the hose if gone unattended. So we do have some charts that are going to give us some estimates. Again, they are estimates of how long we can expect. And one of the things you'll notice is the RPM, the revolutions per minute at the bottom going across. As that increases, the faster we run that, the number of hours that that hose is expected to last is going to go down drastically. So, of course, these hours are estimates, but you can see that for sure, one thing is the faster we run that, the lower we can expect that hose to last. So, one of the good practices when we purchase that pump, if we can go up in size and run it slower, that's going to lead to increased success for the customer. They're going to have less maintenance time involved with the pump. The maintenance time is pretty minimal to change the hose. You'll see that even though while Raphael's doing this and he's just making discussion during that, it still takes less than a half an hour to change out the hose on that pump. To calculate that, again, we're going to base the calculation with speed in mind. We're going to use the number 7 million. Probably might be a little bit of a conservative number. It might be a little bit of an optimistic number, depending on, again, some of our other process situations. But 7 million is the number of restitutions. And restitutions are once we compress that hose with one of the rollers going over it, the restitution is it restoring back to that cylindrical shape that we needed to go to pull in the fluid. If it doesn't fully respond or fully restore to that cylindrical shape, it's not going to pull in as much fluid, and we're going to get decreased flow out of the hose. So that's one of the key factors that's going to let us know it's time to change the hose. As we get the flows going lower and lower, which might mean that we have to ramp the speed of the pump up if we're monitoring. That's one way to compensate for it. We can increase the speed slightly, at least until we're able to get a new hose so that we can make the change and get back to normal running conditions. But that restitution, that restoring back to cylindrical, is what's important to us. So we're going to go that the hose life can expect about 7 million restitutions. Now, each revolution, we have 2 compressions of that hose. So it has to use 2 restitutions for 1 revolution. If that makes sense to everyone, I hope. So if we use the number 7 million divided by 2, again, that's the number of rollers that we have in the pump, divided by the pump speed, or the pump RPMs, how many revolutions per minute we're going to make, and then we're going to divide that by 60 to get the number of hours instead of the number of minutes that hose is expected to have usage for us. So just a quick example, if we took 7 million divided by 2 for the number of rollers that we have, and if we're running at 40 RPM, and we divide that by 60, you'll see that the approximate hose life is going to be about 1460 RPM, or I'm sorry, 1460 hours. Now, if we're able to slow that down just by 10 RPM, you'll see 7 million divided by 2, divided by 30, divided by 60. Our hours to expect out of that hose life is going to increase by over almost 500 hours. So you can see the significant gain by reducing the speed of the gearbox. We're increasing by about 25%. One other thing that's critical to us, of course, is that we get the right hose and the right application. So we do have some charts to reference on that. You can see here, natural rubber, that's going to be probably the one that we recommend first and foremost in most applications. If we don't recommend that, we're going to look at the chart and maybe go across, some of those things like vegetable and animal fats, where natural rubber gets a poor resistance to that. We're going to switch that to something like a Bunirubber. Sorry about that. Take just a second so we can edit that out. So that Bunirubber, you can see is going to be a fallback in that case to the vegetable and animal fats, mineral oils, hydrocarbons, things of that nature. Okay. So now we have some of these things documented. We have charts to recommend. We use Raphael's experience. We're going to get the right pump, the right hose to the customer. And again, that's our goal, just like in our other pumps, that we make the right choices for the customer so that they're going to have a very long life out of the pump, out of the hose, at least as long as they can. But nonetheless, the hose is a maintenance item. It's a wear item. It is going to be needing change. So without anything further said, Raphael is now going to show us how to change the hose on our Dulcoflex pump. Here we're using the B series pump.
All right, good afternoon, everybody. Thanks for joining us. We're going to go over the basic procedures of how to change the hose on the Dulcoflex B series pump. One of the things that we'll just go over how easy the maintenance is. A person who has very little knowledge or experience in changing a hose may do this project in maybe 30, 40 minutes, and that's actually not bad. But somebody who does it very frequently will probably have this task done in 10 to 15 minutes, if not less, because they're very proficient at it. So one of the advantages of these pumps is when we're talking about hose changes, the pump does not have to leave its place. It can stay on site. The maintenance personnel can do the hose change right there on the spot, not have to lose time, and get that pump back into its application as soon as possible. So let's go over the basics. This pump here that we have has a BFD installed. You can see right there. And we're just going to go ahead and start taking this thing apart. One of the main things here is I'm going to show you is this pump's only going to be worked with this one single tool. That's all we need. Everything in this pump to change a hose will be done with a simple 13mm wrench. Why is that important? Here's why it's important. A lot of specs call for pumps that do not have special tools. Well, that is not a special tool. That's just one single tool that is used to do the maintenance procedure on it. So let's go ahead and get started. First of all, what I'm going to do is I'm going to take the cover off of it. You do not need to take the cover if you know that the hose is bad and your rollers are good. But we're going to go ahead and take the cover off to show you how to inspect the rollers as well and make sure that everything is good with it.
One thing that we do want to suggest is before we do maintenance on the pump, just like any of the pumps, we want safety first. So please flush out the line and relieve any pressure that's in the system.
Thank you, Jim. All right, so we're just going to get started by removing the cover from the pump. The cover removes very easily. There's a gasket here. You can see that gasket. Make sure you do an inspection on the gasket that there's no tears or any wear on it. Very simple item to replace if need be. As you can see on the inside of the pump now, we have two rollers. For this presentation itself, we went ahead and loosened one of the rollers just to expedite and make this presentation a little quicker. But you can see the two rollers. This is what Jim was talking about earlier. These two rollers, one rotation of the two rollers on the hose makes one revolution. All right, so two compressions of the rotor makes one revolution. All right, we're going to go ahead and remove one of the rollers. You can see the roller comes out very easily. So when you have your roller removed, you can do an inspection on this roller. Make sure you have free movement. Make sure that the roller has free movement and there's no, it's not seized. Very important if the roller is seized, what's going to happen, the roller now becomes a shoe. And now what's going to happen is it's going to provide or apply more pressure to the hose, and it's going to decrease your hose life. So very important for you to do a quick inspection on that roller. If you need new rollers, we have these available. What I recommend is to keep a set in your spare bin. So if you do have to change that roller, you can go ahead and easily put it back on. So contact us here at ProMinent if you need more information about getting some rollers. You'll see here, this is there's two bolts that are left. These are your guide bolts. Do not remove your guide bolts unless you're removing the shims, which are on here. Those guide bolts are there just to make sure that the roller bracket goes on correctly to the rotor. The next thing we're going to do is we're going to remove the press flanges, which are right here, this one and this one. Once again, your 13mm bolt, your 13mm wrench.
The press flanges that Raphael is removing right now make an end connector so that none of the hose is exposed to outside of the pump. If the hose is going to rupture, it's going to rupture inside and it's going to be contained in there. And that press flange, Raphael will show that there are actually two different parts for each of those press flanges.
So, as Jim was mentioning, there's two pieces to the press flange. As you can see, here are the two pieces. One piece, and let me turn the pump around so you can see how that fits with the pump. You can see on the face on this side of the pump, there's two bolt places for your bolts to go into. Your press flange makes up like this, and you have two pieces, one with bolts on the side, and then the other one, bolt holes on this side, and bolt holes on the opposite side. So when you put them together, they press against the fitting, and you can't go. There's only one way to put them on. One goes on this side that holds the press flange to the pump case, and then this side, those bolt holes hold the press flange to each other. The next thing we're going to do is remove the fittings. Sometimes they don't come out this easy. You may have to cut them out. But for the most part, they do come out pretty easily. You want to inspect your fittings. Make sure that the threading is good and that your grooves are not worn. These grooves are what the press flange wraps around to secure the hose to the press flange. Okay, so just do a quick inspection. If you do need the fittings, we have these available as well. All right, now we're ready to remove the hose. Sorry. Now we're ready to remove the hose. What we're going to do here is, you can do one or two ways. You can use your VFD to move the rotor around to feed the hose out. If you do not have a VFD, you can do one or two things. You can remove the fan cover off the motor and rotate from the fan blade, or remove the motor itself. It's only 4 bolts, and use the input shaft of the gearbox to rotate the rotor. So that clears the rotor.
Let the rotor do the work for you and help feed the hose through.
The hose is removed, and you can shut off your VFD. Once it's out, you can inspect your other roller just while it's installed. Make sure that it has free movement, just like we're showing there. All right, so your hose is removed. All right, make sure that when you do remove the hose, that you're installing the same material hose that you're using, because if you put a different material with your chemical, like Jim mentioned before, your hose will fail rather quickly. We have different hoses to provide. We have natural rubber hoses, this one is a natural rubber hose. It's a black hose. We also provide EPDM hoses, which is a black hose with a light blue stripe down the hose. We provide a Hypalon hose, which has a green stripe down the hose. And we provide a Buna N hose, which is a red stripe down the hose. Okay, so that's how you know the color coded for each type of material. All hoses, no matter what size, for the Dulcoflex line, they're all color coded. When you're ready to install your hose, make sure that you have the recommended grease that we provide, which is our part number 7761440. One of the things that we recommend, do not use any other type of grease. And the reason why is because this is a food grade grease, there's no oils in it. If you use a grease that has oils on rubber, you know what's going to happen. It's going to eat away at the rubber immediately, and it's going to cause early hose failure. So make sure that you use this grease provided by us. Use it liberally. Do not skimp on it. Use as much as needed, because obviously you need to have that hose and the rollers lubricated.
If you have multiple pumps at the same site, you can buy a small jar as well. Or if you have a lot and you do preventative maintenances routinely, you can get a small pail of that grease as well. We have that available for you.
Yes. They come in the 4-ounce tube, a 1-pound tub, and an 8-pound tub. All right, so once we're ready to put our new hose in, make sure that you take your grease. I'm not going to grease it up right now. Obviously, we're going to put the same hose, but when you get your new hose, grease it up. Make sure that it's all lubed, and you're going to install your hose. Once again, you're going to use your BFD and let it do the work. Just feed the hose. Once that roller grabs it, just let it do its job. Go ahead and rotate it through, Jim, one more time. Let it go through. One more, a little bit more. All right, so you have your hose installed. Use whatever grease you have left in your tube to make sure you lubricate the rest of the hose and a little bit of the rollers. Make sure that all that's covered. All right, so now it's time to put, you can put your fittings back on. Once your fittings go on, then you can install your press flanges. Remember, you have the press flanges with both sides. I'm going to turn the pump around one more time so you can see the installation. It wraps around just like this. All right, and that secures and you're going to repeat the same process for the bottom port. We're not going to put it on, but just repeat and tighten everything down. Once your roller's ready to go back on, you place it inside, line it up to your guide pins. It falls right in. Use your 2 bolts that you removed. Tighten them down. Once again, we will not tighten these down for the presentation, just for time.
Those use the same 13mm wrench.
All right, so your roller's installed. Now you kind of put your gasket back on.
If that gasket was damaged or ripped in any way that you noticed when you took it off, it's good at this time to replace that as well.
Install your cover. Sometimes these things are made to fit, so you got to get it on just right. Once that's all secure, your press flanges are good, and you're all tightened up, you can go ahead and resume operations on your pump, and you're ready to go. So that's the basic information about changing a hose on the DFB pump. If there's any questions, let us know, and thank you so much for being with us today.